Hey guys, this is Ankit and welcome to the Terraform GCP task series. We are doing a list of basic tasks to get ourselves familiar with Terraform for GCP. We are following the DevOps Engineer and SRE learning path, also available at cloudskillsboost.google/paths. You can always get more details by going to the repository thecloudterminal01/learn-devops. For today's task, we have the following objectives. We will use load balancing modules for Terraform. We will create a regional TCP load balancer. We will access our minimal PHP app on an external IP. We will also go through and understand the code base. The total amount of time we will be spending will be around 19 to 22 minutes. So let's begin. Let's first go through the code and understand the different components that we are going to create. You can clone the repository using this URL yourself. I've already cloned the repo and I have only the relevant components over here. I've added a few comments in the code base so that it is much more readable. Let's first go through the locals.tf file present in Terraform Google LB example basic folder. Now this code is an example of using Terraform's local block to define a variable within a nested object. The object defined in health check variable represents a health check configuration for a load balancer and other similar infrastructure components. So these are the different key value pairs that we have. The request path is set to /path, host is 1.2.3.4. These are all dummy values that we are setting up. Obviously, when you are setting these health check values for your own application, you'll have to change them as per your application's health check URL. So these are the contents for provider.tf file. In variables.tf, we have these variables. The region is US Central 1. Project ID description is this. Image family is Debian-11. Image project is having this description and this is the default value. The required Terraform version for our project to run should be greater than or equal to 0.13. In the outputs.tf file, we want to get the external IP address of load balancer default, which is declared in main.tf file over here. Let's move to network.tf. Over here, first we are trying to create a Google Compute network with the name load balancer module network. Inside the network, we will have subnetwork with this CIDR range, and the name of the subnetwork will remain the same. We'll create a Google Compute router with the name load balancer module router, and we'll also create a cloud NAT with the name as load balancer module cloud NAT. Now let's move to main.tf file. Inside the main.tf file, this block of code defines a Terraform data source of type template file named instance startup script. And if we go to the instance startup script, which is gceme.sh.tpl, this is basically a bash script that installs Apache and PHP on Debian-based Linux machine and sets up a web page that displays the metadata of Google Cloud instance that the script is running on. You might need to change the path to the template file depending upon how you are running this Terraform code. For us, we'll be just cloning the repo, going to the directory and running the code, so it should work out of the box. Over here, we are creating a Google service account with the name as instance group. In this section, we are creating an instance template using this particular module as our source. After that, we are creating a managed instance group, again using this as the source. These are the target pools for our managed instance group. In this section, we are creating 3 different load balancers. The name of those load balancers are basic load balancer default, basic load balancer no health check, and basic load balancer custom health check. Now if you see that these load balancers are using source as dot dot slash dot dot slash, which essentially means that they will be going to this directory and after that basically go to this main file and create resources as per the configuration we have defined over here. Over here, the first block of code, that is the locals block, defines a variable with the name as health check port that is set to this value. Then we are creating a Google Compute forwarding rule. Now in GCP, a forwarding rule is a configuration that specifies how traffic should be directed to a load balancer. A forwarding rule specifies the IP address, protocol, and ports that the load balancer should listen on. So this particular forwarding rule will be created for all three different load balancers that we have defined over here. Next, we have Google Compute target pool. In GCP, a target pool is a group of virtual machines or IP addresses that receive incoming traffic from a Google Cloud load balancer. The target pool defines a set of virtual machines or IP addresses that should receive traffic, and the load balancer routes the traffic to the instances in the pool based on load balancing algorithm configured for the load balancer. So this particular resource will be created for all the three load balancers that we have defined in this file. Specifically, the health check attribute is set to empty list if var.disable health check is set to true. Otherwise, it includes a reference to the HTTP health check resource. So if you go to this main file for basic load balancer no HC, the disable health check attribute is set to true. Next, we are creating a Google Compute HTTP health check resource type. Now this resource type creates a HTTP health check to verify the health of instances. It specifies the project name, check interval, healthy threshold, timeout, etc. The count parameter is used to conditionally create a resource depending on the value of disable health check variable. If disable health check is set to true, the health check resource will be created, otherwise it will not be created. So basically, we'll be creating health check resource for basic load balancer default and basic load balancer custom health check. We will not be creating this for basic load balancer no health check. Next, we are creating a Google Compute firewall rule. In GCP, firewall rules are used to control network traffic to and from virtual machine instances. They act as a barrier between your instance and the internet or other networks, allowing you to specify what kind of network is allowed or blocked. So this particular resource will be created for all three different load balancers, and it will be created with the name which will be same name as that of the load balancer and appended with -vm -service. This is the second firewall rule. This particular firewall rule will be created with these names. It will be created only for these two load balancers. It won't be created for no health check load balancer. This is the count variable logic that defines whether it will be created for a particular load balancer or not, depending upon the value of disable health check variable. In this particular firewall rule, we are basically allowing TCP traffic from these port ranges and this source ranges. These are the rest of the files that we have. This is the versions.tf file. This is the variables file. This is the output.tf file. You guys can go through these files as well. We are basically declaring a bunch of variables and outputting a bunch of values. Let's also go through the screenshots of the resources that we are going to create and the ones that we discussed just now. So this is the service account that will be created for us. This is the screenshot for the VPC network. We will be creating load balancer module network. This is the subnetwork that will be created inside this VPC network. This is the screenshot for the cloud router. This is the cloud router details page. This is the cloud NAT screenshot, cloud NAT details screenshot, managed instance group screenshot. This is the details page for the managed instance group. These are the two VM instances that we will be creating, and these instances will belong to this managed instance group. This is the instance template page screenshot. This is the details page for the instance template. These are the three different load balancers that we are going to create. This is the details page for basic load balancer default load balancer. Screenshot of the minimal PHP app that we will be accessing using the external IP of the load balancer. This is the screenshot for firewall rules that we will be creating. This is one of those firewall rules in details. Screenshot for the health checks that we will be creating. This is one of those health checks in detail. The target pools that we are going to create. These are the forwarding rules that we will be creating. So let's start with our first subtask. I will clone the repository and move to this particular folder. Let me export the value of Google project, run it over here, run Terraform init. Let's run Terraform apply. We'll enter the value of project ID, click enter, authorize. 21 resources will be created, and let's now wait for the resources to get created. Now all the resources have been created. Now let's go through those resources and understand how they are related to the code base that we just executed. So we should have a network with the name as load balancer module network. So let's go to view all products, go to networking, let's go to VPC networks, and over here we have a network with the name as load balancer module network. Inside this we should have a load balancer module subnetwork with this CIDR range. So we have a subnetwork with the same name, and this is the CIDR range. Next we should look for load balancer module router and load balancer module NAT. Let's search in Google Compute router. So we have a router with the name as load balancer module router, and if we go inside this is the details page, and this is the cloud NAT instance with the name as load balancer module NAT. Next, we need to look for resources in this file. First, we need to look for Google service account with the name as instance group. For service account, we can search for service account over here and open it in a new tab. So our service account is created with the name as instance group. Next, let's look for instance template and managed instance group. Let's go to load balancing page. Over here we'll see that 3 load balancers have been created with the same name that we described. If we click on any of those load balancers, we will see that this is the corresponding instance group and these are the corresponding instances. This is the instance group details page and these are the 2 instances in the instance group. Over here you will also find the instance template that we have created. This is the details of the instance template. These are the VM instances. Next, we need to look for the load balancers and the corresponding resources that will be created for these load balancers. For load balancers, we will go to networking services and load balancing page. Over here, we'll see that the 3 different load balancers have been created with the same name that we defined over here. We can also go to load balancing components view and over here we will see the forwarding rules and the target pools. Over here you will see that for the basic load balancer no health check target pool, the health check is set to none. This is because in our code base we had defined a condition which said that the health check attribute is set to empty list if variable.disable health check is set to true, and this particular health check is set to true for basic load balancer no health check. Now let's go to the firewall rules section. I'll go over here and these are the different firewall rules that we have created. Finally, let's visit our application using the external IP addresses that have been created by the load balancers. First, we will check the external IP for custom health check load balancer. We'll see that both the instances are unhealthy. This is because we have set up an incorrect health check for our application. If we go to the custom health check, we'll see that it's set to a random host ID and a random path. As a result, the health check is failing. So if I go to the public IP address port 8080, I won't be able to visit the application. If I go back to the list of load balancers, the next load balancer is the load balancer default. For this particular load balancer, all the health checks are passing. If I go to the public IP address of this load balancer and the exposed port 80, I should be able to access the application. So this is our minimal PHP backend app. Let's go back to our list of application load balancers. Now, basic load balancer no health check is the load balancer that we created without any health check. As such, it will be sending traffic to all the instances regardless of their status. So if we go to the public IP address of this load balancer and the exposed port, we should be able to visit the application again. So this completes all of our subtasks for today. Hope you enjoyed the video. Let me know your views, opinions and disagreements in the comment section. That's all for now. See you in the next video.